Okay, so I'm going to explain a little bit more about solving systems of equations by graphing. So I'm going to skip a couple of these pages because we covered them in class. We did this one in class and we found where the solution was, and we talked about ways to find an intersection, and I think we discovered that we could also use I don't know what we discovered. I'm going to have to wait till tomorrow to see what we did. All right, so then let's talk about solving this one by graphing. So the first one has already been set to y equals, so you can just graph that. And then the second one you could graph any way you like, but I'm going to go, well, let's solve the first one. Let's go graph that. So I've got, here, let me get this. I'm using a different type of technology, so I'm not doing too well with that. Okay, so the first one is in slope-intercept form, so I know my y-intercept is 3, and my slope is 2, so I'm going to count and go up 2. I'm going to go over 1 and up 2. That's my rise over run. All right, and I'm just making a little dotted line right now. And then I have like a little line drawing thing that I can use here to make sure my line is straight. You would have to use a ruler. All right, so then let's look at the other one. We've got negative 4x plus 2y equals 6. Well, it's pretty easy to solve if you would just cross out the 4x. You got 2y equals 6, so we know y, the y-intercept is 3. Well, that seems to be our solution, but let's just go and do that anyway. Just to be sure, I'm going to go and erase this work here real quick. And let's say you couldn't see that because let's say you got, cross that out. You got negative 4x is equal to 6. Divide by negative 4, x is equal to 6 over negative 4. Put that in lowest terms. It's 3 over negative 2. So negative 3 halves is going to be your x-intercept. Oh, look at that. Look what we got. This might be worth a good look-see to do together in class. I forgot about this one. This is actually the same line as what we had before. They just look different, don't they? So this line goes right on top of the line we had before. So this kind of solution that we have, in case you didn't catch on the first time, those are infinite solutions. So we've got the same line. You could do that by also solving for y. Let's practice solving for y just to be sure. So I'm going to subtract or add my 4x to both sides. And I've got 2y is equal to 4x plus 6. Once you divide by 2, look at that. You got y equals 2x plus 3. They are the same line, so they have infinite solutions. All right, let's see which other one I skipped during class today. I think we did that one in class, but we didn't do this one. So let's go ahead and solve this by graphing. Now this one can be done. Let's go ahead and just solve both of them for y because it's much easier because 4 is not a factor of 3 or is not a multiple of 3, so it's going to be kind of tricky to graph. So I'm going to just come over here. I got negative 3x plus 3y equals 4. All right, add 3x to both sides. And I got 3y is equal to 3x plus 4. And then once we divide by 3, we get y equals x plus 4/3. That's one of our lines. And then let's go do the other one. And we're just going to add x to both sides. And we've got y equals x plus 3. All right, so let me pull up a graph here real quick. Okay, so I graphed both of those. And as you can see, the slope is exactly the same. So these are going to be parallel lines. All right, and they have no solution at all because they're never going to intersect. We have no solution. All right, so that's how you would solve and look for some of the answers for graphing by solving by graphing. Another way you would do that is you would go and once you get your y equals in there, say you've got y equals, I don't know, 2x plus 1. I'm going to make this real easy. Y equals x plus 1. All right, so we know that they're going to intersect at the y-intercept. So instead of doing where you're going to have the graph, you just go ahead and you're going to plug in, okay? You're going to look for where you have repeating x's in your table, and that's going to be the intersection. The intersection is going to be at 0, 1. All right, so your assignment is on this page right here, 71, and you've got some problems to do, and they're in the post that I posted, and they are due on Monday. All right, have a great day.